We are sitting now in the House of Cultures of the World in Berlin, Germany, at a meeting that opens a very interesting project called the Anthropocene Project. Okay, my name is Will Stephan. I'm based in Canberra, Australia, at the Australian National University. But I also do a fair bit of work in Europe, primarily based at the Stockholm Resilience Center in Sweden, but also working with colleagues in Potsdam and other places in Germany. I'm an Earth system scientist, which means I study how the Earth works. So I don't specialize in any one area, although I do a fair bit of work nowadays on climate change. But my background actually is a range of disciplines, starting way back at the beginning of my career as a chemist, then getting into environmental physics, then getting into ecology. And then, because I was director of a very large international global change research program, I had to start learning about what the oceans are doing, the atmospheres, the ice, and so on, basically how the Earth operates. So more recently, I've tried to focus my attention more on other areas than natural science, economics, social science, even the humanities, particularly history, to understand the role of humans in the Earth system. Because the more and more we study about how the Earth operates, particularly in this present period, we understand that humans are equivalent in many ways to some of the great forces of nature, and we need to start to understand humans as well. So I guess in my own career, I've been driven by the question, the theme, the problem that I'm interested in, and then having to go out and learn other areas of science, other areas of scholarship like history and so on, to be able to make sense of what we're observing. Well, the word Anthropocene, the first association that comes to my mind is pretty obviously humans, from anthropo. But it also has the implication of change, of moving away from a stable global environment, of dynamism, of uncertainty about where we're going in the future. First of all, the word Anthropocene and the concept of Anthropocene, first and foremost, from a natural science perspective, is useful. And that's why we use it so much now. Because we've been studying how the Earth is changing for quite a while now, and even some people back in the 1800s were looking ahead and saying humans are going to be an important force, already are, and will be more so in the future. So we've, for a long time, used the term global change. We've used it since the 1980s to try to describe all the changes, not just climate change, the loss of biodiversity, the change in the big cycles of elements like nitrogen and phosphorus, the changes in the water cycle, the changes in the ocean of marine ecosystems, ocean acidification, issues like that. All of these changes which are occurring, which are at the global scale, plus and interacting with all the human changes, the changes since the Second World War in our economy, globalization, how we're connected, our value system, ever more consumption, and so on. So all of these things together are global change. And that's been sort of a hard term both to use and to communicate, because people say global change, do you mean economy? Do you mean something else? When Paul Crutzen in the year 2000 sort of blurted out the word Anthropocene to describe all this, it suddenly resonated. It made sense to the scientists around the table. Say, this is a useful word. It actually pulls together all the changes we're studying, all the changes we're observing, and it puts it in one big concept. Humans are moving the Earth into another state, basically, is what that's saying. So it's been very useful now for a decade in the scientific community, and it's spread very rapidly through scientific networks. And you'll find it used ever since about 2002, 2003. It appears more and more in scientific papers. What's fascinating is the last 2 or 3 years, because it's broken out of the scientific community. It's done that in a couple of ways. One is it's gotten right out into the public, and it's done that through magazines, popular publications like Le Monde in France, which had this very interesting cover of a human eating away at a big pudding that looks like planet Earth. And of course the Americans have gotten into it with all these massive cities and motorways and all this sort of stuff. People now outside of science are conceptualizing in their own minds what the Anthropocene might be, the age of man. And of course The Economist has gotten into the act too. So we see it spreading rapidly. You see the term now appearing in newspapers. You see it in television programs. I think now that it's spreading into other areas of scholarship, of research, like the humanities, is really fascinating because they have a lot to bring to the table. Those of us who are scientists like to sort of use our scientific minds to look at the concept of the Anthropocene. We're looking for evidence, we're looking in the stratigraphic record, we're looking in other records. But in fact, the word, when it gets out of the natural science community, is a very provocative word. It's a very profound word. And the reason it does that is it challenges the way humans think about themselves and their role in the world. It almost forces people to think about that because it's saying that the assumption we've had ever since we've evolved is that there's this huge earth that we live on. We change our local area, we interact with it, but this is such a huge planet and it's got its own dynamics, its own climate. We can't affect that, we have to learn to live with it. Now Anthropocene is saying, wait a minute, we're actually starting to modify our own life support system. The whole global planetary environment that we depend on, we are now influencing it. That really shakes a lot of people's beliefs, a lot of people's worldviews. This is why the humanities are so important, because that's what they study. They study cognitive processes. They study social relationships. They study how people think, how they perceive, how they interact. And this is a new big change, I think, in the history of humans in terms of how we relate to the environment around us. So I think that really is an important development in taking the Anthropocene beyond the natural sciences into other areas of research and scholarship and into the general public. So these last 2 or 3 years have been very exciting. As a natural scientist, it's more fun for me to sit back now a little bit and be an observer of how these other areas of research are grabbing the concept, reinterpreting it, putting into new contexts and so on. It's sort of fun to see this happen. Well, the issue of what does the Anthropocene, what does Earth system science mean, what does it tell us, quickly gets us into policy, it gets us in institutions, it gets us into governance. Traditionally, the bridge between that sort of fundamental research on global change, Earth system science, Anthropocene, have been the big assessments like the Intergovernmental Panel on Climate Change, the IPCC, and the newer one on biodiversity and so on. And they try to take the science and reinterpret it and repackage it and contextualize it in ways that are useful for policy. It's interesting that I think that relationship is coming back the other way. Scientists are now listening more to people in the policy and governance sectors. And as they struggle with, well, what does this mean in terms of how we manage the planet? How do we get humanity together to make laws, regulations, agreements, treaties, whatever, to start to manage the whole Earth, which is an entirely new challenge for humanity. What this is doing is it's feeding back challenges into the science community and helping to guide our research. So it's really a two-way street now. I'll give you a good example of that. There's the concept that's out now for 2 or 3 years called planetary boundaries. This is a concept that in a way has been driven by the policy imperative, the governance imperative, that now that we are, as humans, a global force, we're in the Anthropocene. Well, how do we respond to that? So the planetary boundaries was a direct way to start thinking right from the beginning of the research to say, what are the policy needs? In fact, we heard from policy people at the beginning, all right, so what do we do about this? We've done something on ozone hole. We're struggling to do something on climate change. We've had the Kyoto Protocol. We have many negotiations, but we don't have any really good, conclusive, really powerful new institutions to deal with this. Well, the planetary boundaries approach has really tried to simplify the science and say, instead of trying to say limits, there's a limit to what you can use here, a limit to what you should use there, let's look at the whole Earth and say, what are the intrinsic inbuilt limits to how the Earth operates? So we can define, if you like, a playing field. Just like when you play a good football match, the football players don't run everywhere, they have boundaries. And then they can be as creative as they want in trying to kick the ball into the goal. Same way with humanity. Earth provides a playing field. We have to understand the limits of that playing field, and that's what science is trying to do. It's trying to inform governance and so on. Then governance has to make the rules of the game. Just like in football, you can't do everything. You can't use your hands unless you're the goalkeeper. There are rules to what you can do. You can't push other people down. And so just like that, using that analogy, governance and so on now has to say, all right, if science can help us define a playing field, how do we define the rules in which humans operate in there, respecting the boundaries of the playing field? That's the point that we're at now. There are some positive examples out there. The ozone hole issue and the Montreal Protocol is often given as an example, and it is an example. The reason it worked is it's pretty simple. There are only a few artificial compounds that were causing that problem, and we could quickly find substitutes. We're now grappling with more difficult governance issues. How do you slow the rate of biodiversity loss? Well, there are multiple pressures. They operate at a lot of scales. Some of them are within national jurisdictions. Some of them like poaching of rhino and elephant ivory and horns and endangering those species comes through a globalized system. So the challenges for governance are pretty severe, pretty challenging. Interestingly, I think the social sciences are rapidly picking up that challenge. There's a new project internationally that's going to be part of the new Future Earth program on Earth system governance, looking at, do you need multiple conventions? We have a convention on climate change. We actually have a convention on biodiversity loss, and so on. They're not very effective yet. How do we make them more effective? And there are a lot of scholars who are now saying, how do we cross-link them? How do we make sure that what we do to try to solve the climate change problem in terms of governance isn't counterproductive for biodiversity? In other words, trying to store carbon in land can be done in ways that are good for biodiversity and in ways that are bad for biodiversity. How do we design the conventions to make sure that you get these synergies between the conventions? So I think there's a lot of research on the social science side that is getting to quite practical issues of convention design, convention interaction, how do you enforce these things, what are the penalties for not complying, and so on. We have a long way to go, but it's an active area of research, and I think maybe 5, 10 years we can look back and say we've really made some progress here. The new program, Future Earth, is an international integrated program to try to look at future pathways for humanity in this dynamic situation, the Anthropocene. It basically brings together 3 existing global change research programs. One of them is IGBP, the International Geosphere Biosphere Program. Basically, it looks at the big element cycles, what we call the biogeochemistry. Another one is Diversitas, which focuses on biological diversity, as the name indicates. The third one is the International Human Dimensions Program, which looks at things like Earth system governance, looks at things like transformative pathways for low-carbon societies, and so on, looks at human security. So traditionally, those 3 programs have interacted, but they've been largely separate. This is integrating them in one program called Future Earth, where they work much more closely together and much more closely with the policy sector. Well, geoengineering has, or is increasingly proposed now as a possible response to the climate change challenge. In other words, if we cannot reduce emissions of greenhouse gases fast enough and deep enough, and the temperature is rising to levels which everyone agrees are dangerous, should we try to engineer the Earth system to cool it down? One of the common, probably the most common approach that's proposed for geoengineering is what's called solar radiation management, which means trying to decrease the amount of sunlight that's heating the Earth's surface, so we bring the temperature back down. One way to do that is to mimic what volcanoes do. Very strong volcanoes put up a lot of particles into the stratosphere, the upper atmosphere, and those particles scatter some of the sunlight coming in, cool the Earth. The idea for geoengineering is that humans put continuously large amounts of these sulfate particles, sometimes called sulfate aerosols, into the stratosphere and put the right amount to cool, to counteract the greenhouse gases, which continually go up, and bring the temperature of the Earth back down close to what it was before anthropogenic climate change started. Very controversial topic because the science behind that is very incomplete with a lot of uncertainties which can be quite dangerous. One such uncertainty, or one such certainty I should say, is that one of the side effects of increasing carbon dioxide is the acidification of the ocean. Carbon dioxide dissolves in water, in ocean water, creates carbonic acid, and that increases the acidity. Carbonic acid in particular is important because most of the marine organisms that form shells, like corals, rely on carbonate ions in the seawater to come together with calcium and form their shells. Increasing acidity of the ocean affects how much carbonate is available. So it's going to have a big impact, negative impact on ocean ecosystems. We can already see it today with the present amount of CO2. Geoengineering in the form of putting aerosols in the stratosphere and allowing greenhouse gases to continually increase would not solve that problem. It would make it worse. It would mean that we would devastate the marine ecosystems around the planet. Second point, when you put aerosols in the stratosphere, you not only reduce the temperature, you change rainfall patterns around the world. We see this when we have a very intense volcano like Pinatubo. That changed rainfall patterns. The problem there is our modeling ability, our understanding of the system is not good enough to say how we are going to modify those patterns, where the rainfall is going to go down, where it's going to go up, and so on, where the pattern is going to change, seasonality. This is important because humanity has developed our industries, particularly our agriculture, cities, and so on, based on the rainfall patterns of the Holocene, within the variability we've come to know. If we change that significantly, and we almost surely will through those types of geoengineering techniques, we don't know how rainfall is going to change. But areas that are currently agriculturally productive may lose a lot of that productivity. Rain may shift somewhere else. Some cities may start to run out of water. Other areas that are currently dry may get wetter. We don't know. It's going to cause a big dislocation in human society, even if we bring temperature down. The third issue, and this gets straight to the governance issue. This is a global problem. Who has the right to say, I'm going to start sending up aerosols into the stratosphere? To give you an idea of how feasible this is, my colleague Paul Crutzen, who first used the word Anthropocene, is an atmospheric chemist. So he knows a lot about this issue. He did a quick calculation if we wanted to reduce the temperature 2 degrees to counteract a 2-degree warming. How much aerosol would it take? So he calculated the amount of aerosol. He calculated how much you could put on top of a rocket, a Russian rocket, for example, and he calculated how many rockets you needed per year to do that and how much it would cost. And he came back and he said, do you realize that one human being, the wealthiest person, say Bill Gates, can not only change the temperature by 2 degrees, he can throw the world into an ice age. So it is feasible for small groups of wealthy people, let alone a country, to actually do this. The technology is there. It's not that expensive in the grand scheme of things. So we have a big governance issue. If someone decides without a global agreement to do this, if a country or a regional group of countries decide to do this, and it takes rainfall away from someone else and devastates their agriculture, who's responsible? Huge legal issues, huge governance issues, and we have a long way to go to solving them. The final thing I'll say about that is there is an enormous risk if we have a governance system that fails after we've put a lot of aerosol in there. We're counteracting a lot of greenhouse gas which is built up, and we have a governance failure. We stop sending the aerosol up. We're suddenly faced with an enormous amount of greenhouse gas, backlog of heating. Suddenly you take the brake off and you have a rapid out-of-control warming, which would be chaos for humanity. It would almost surely collapse civilization. So the risks are absolutely enormous that if we don't get this governance issue right, and remember, you've got to keep a stable global governance system for decades and decades. Humanity's never done this. So there are enormous risks with geoengineering, far greater than the costs associated with actually getting emissions down. Now we've got to have that conversation around the world, and we have to be absolutely hard-nosed about the risks associated with geoengineering. I think the concept of the Anthropocene and the concern that there could be some big apocalyptic collapse of society ahead will focus us to think about some fundamental issues that we need to think about. A couple of these are, what is our relationship to the environment? Now, as we go further into the Anthropocene, more and more of us live in cities. We're cut off more and more from the rest of nature around us. And I think that is raising questions of how do we reconnect with the biosphere, with the natural world around us. So that's, I think, one thing that's very important. Another thing is what really contributes to our well-being, what makes us feel healthy and happy. It's very subjective, but there's actually been some research on that. And that research tells us that ever-increasing wealth and consumption does not lead to enhanced well-being or happiness. If you're very poor, of course, if you become wealthy, your well-being improves. You can get better health and so on. But once you reach a certain level, and the wealthy countries are way beyond that level in terms of per capita income, raising your income further, raising your wealth further, raising your consumption further, does not lead to increased well-being. Other things affect it, relationships, and so on. So if we actually have a good societal discussion about the fact that we want to continually increase our well-being, and so far we simply equate that to GDP or wealth, we need to break that nexus and really have a good discussion about maybe there are other ways of measuring well-being. Maybe there are other ways of measuring an economy that takes into account the non-monetary, non-wealth part of it, and so on. I think this is forcing us to realize that the sort of transformation that a lot of us scientists are talking about and increasingly other people are talking about is not a frightening thing. We're not going to lose this wonderful, extremely wealthy, highly consumptive world. Or if we do, we choose to lose it for a good reason. We're going to enhance our well-being. So I think for the first time, I'm actually starting to see not just academics. I'm starting to see people in business, people in society question the growth imperative, questioning this tight coupling between wealth and well-being. I see that as a healthy sign. And just as in the natural world, where we have these so-called tipping points, where you push a system past a tipping point, and then you get an abrupt change, like the shutdown, perhaps, of the North Atlantic ocean current. Just like that, I think there are tipping points in human systems. For bad, like the global financial crisis tipped us over a debt edge, but for good too. When enough people decide we're going to go a different way, then you might see all sorts of things happen. Change to low-carbon societies, change to a more service-oriented economy rather than a material consumptive economy, more equity within countries and between countries. Those things can actually start happening fast. And if they do, we can actually get the transformation we need to steer the Anthropocene away from that apocalyptic future. And that's really what we've got to work on in the next 5 or 10 years.